Alright guys, before I jump right into polynomial long division, there's a couple keywords you need to know. You need to know what a dividend is, what the divisor is, what the quotient is, and what the remainder is. I'm not going to bore you with formal definitions, but you are familiar with the three different ways that you can write division. You can write the dividend divided by the divisor equals your quotient plus your remainder. So it looks something like this. 16 divided by 4 equals 4 with the plus my remainder of 0 divided by 16. Now we don't normally write the remainder when it's 0, but you can if you need to fit this general form. The second way you're used to seeing it is the dividend on top of the divisor, in terms of like numerator or denominator, but it is still division. It's dividend divided by divisor. And your answer is still going to be in the same form of quotient plus remainder plus divisor. The way, of course, that works is going to be, give me a quick second, let's make some space here. It's going to be 16 over 4. Well, we know that that's still going to be 4, and of course we can still write it as plus 0 over 16. I don't care if you write it with plus 0, 16 if your remainder is 0. However, if your remainder is not 0, you do need to write it as your remainder on top and your divisor on bottom in this form right here. The way we'll actually do polynomial long division is we're going to have to write it like this. We're going to put our divisor on the outside. We're going to do our dividend underneath the division symbol. My answer is actually my quotient. It's going to go on top. And of course, then we're going to do plus my remainder and division. Remainder and divisor. So you kind of have to know these keywords. If you look on the very first page of class set activity 10, day 2, in the opening paragraph, I also lay these out, what these words are with examples. Through this entire page, and really through this whole packet, I'm using those vocabulary words. So you need to make sure you understand when I say a dividend, divisor, remainder, quotient, that you actually know what I'm talking about, where it is when we're doing division. Alright guys, so now I'm going to get in here and explain how to do polynomial long division. But we're going to start out with a very, very basic example that you did in elementary school. As you see here, I have written 14 divided by 164. Well, polynomial long division and regular long division with numbers is the exact same procedure. In elementary school, you would take a look at 14. And that's two numbers, two digits. You have a spot in the 10 spot and the 1 spot. So you're going to look at the first two numbers in your dividend, and you're going to ask, how many times does 14 go into 16? Well, the answer to that is 1. So, of course, then you only have 1. It's going to go over your 10 spot because you're lining everything up in columns. And then you're going to do 1 times 4, and that goes here, 4. And then we would do 1 times 1, and that gives me 1. And then, of course, in long division, you're going to subtract. Then you do your subtraction. This becomes 6 minus 4 is 2. And then 1 minus 1 is 0, and we don't need to write it. Then we bring this number down, just the very next number. Because we always have to have, if there's two digits in my divisor, whatever I'm dividing in, the dividend, has to be the same number of digits or larger. It can't be less than. From there, I bring my 4 down. And then I ask myself, how many times does 14 go into 24? Well, it only goes in 1 time. Then, of course, we do the same thing. We do 1 times 4, and that gives me 4. And then we do 1 times 1, which gives me 1. We subtract again, and here then we subtract. 4 minus 4 is 0, and 2 minus 1 is 1. So in elementary school, they would actually have you write this as 11 with the remainder of 10. Yes, I know you can do decimals. However, what's important is this procedure right here when you're doing long division, because it's going to be the exact same procedure as polynomial long division. The way I would actually write this as an answer in our general form earlier, where it's going to be your quotient plus your remainder divided by your divisor, it would be 11 plus 10 over 14 Now, of course, we're in high school. We're not going to have things like this. But if it did, I would definitely want you to reduce it to be 11 plus 5 over 7. So that's basic long division. You'll learn this in elementary school. You may have not seen this part in elementary school, but I know you've seen this in elementary school. And you've been doing this for quite some time. So now, let's see how this problem here connects to polynomial long division. In your packet, you see that we have the problem x plus 3 divided by 2x squared plus 10x plus 12. All right, so when you look here, this right here, x plus 3 divided by 2x squared plus 10x plus 12, it doesn't look anything like 14 divided by 164. This has got variables. It has numbers. It has exponents. Whereas over here, you only have 14 divided by 164, and you're used to doing that. Don't worry about it because it's going to be the same idea. When we do polynomial long division, the first thing we have to check is when we look at our exponents, they have to be in descending order and they must be all accounted for. If you look at the example under number 1, I actually talk about that if you have x cubed plus 5x minus 1, you actually need to write this as x cubed plus 0x squared plus 5x minus 1. This way, we have a 3 in the exponent, a 2, a 1, and then this is technically x to the 0 power, so we go 3, 2, 1, 0. So in the example we already have an x squared. We have an x to the first. We have our x squared here. We have an x to the first. And then, of course, this is x to the 0. It also has to be the same thing for your divisor. If your divisor is skipping an exponent, you have to put a 0 in for that exponent. Here we have a 1. And then, of course, this is x to the 0. So everything's already set up for us to do long division. Just like in regular long division with numbers, I always create columns. So right here, right above this is going to be a column for my constants. This is going to be a column for my x to the first term. This will be a column for my x squared term. And my remainder comes over here. This is how I'm going to do it every single time. It's how I learned it in high school. It's how I did it in college. And it's how I teach it. It's really the best way to think about it. All right. Now, just like when we were dividing 14 into 164, we have two terms. We have a spot in the 1 spot, and we have a number in the 10 spot in our locations. 1s, 10s. And that means we had to look at the first two terms in our long division. Over here, we have 1. This is in the x to the first power, x to the 0 power 2. So we want to look at the first two right here. And really what you're going to do is you're going to look at the first term of your divisor. And you're going to look at the first term in your dividend. And you're going to say, all right, I have x squared. What do I have to multiply? Well, I have x. What do I have to multiply x by to get 2x squared? Well, we know that you could set up an equation that says x times some number equals 2x squared. And we could solve for that number. You could divide by x. And so that number, whatever we have to put there, is going to be 2x. So because this is an x to the first power, I'm going to put it in my column with my x to the first power. So I'm going to write 2x right there. Now here, it's the same thing as saying 2x times x plus 3. Sorry about that. I didn't mean to write 13. I meant 3. And then we have to distribute this to both. So we would get 2x squared plus 6x. Well, we're going to write that down. Just like when we did 1 times 4 and 1 times 1, we wrote down the 14. So we're going to do 2x squared plus 6x. Now, when we're doing long division, this is subtraction. So we're going to do the same thing. We're going to subtract, but now we have multiple terms, so you need to use your parenthesis. You're going to distribute your negative sign, and really it's going to become 2x squared Sorry about the little background noise there, guys. All right, so as I was saying, we're going to go ahead and subtract just like we do with regular long division. And of course, we have to subtract each term. So we end up getting 2x squared minus 2x squared, and of course that's 0. And then we're going to do 10x minus 6x, and that of course is 4x. Now just like in long division, after we did the first step of division, we have to bring that next number down to create the number of digits in the dividend and the divisor being the same. Here we're going to have to do the same thing. We're going to have to bring down my next term so we can actually have two terms because my divisor has two terms. So here it becomes 4x plus 12. Then here you look at the beginning, the first part of your divisor, you look at the first part of your dividend, and you can actually say, well, some number times x has to equal 4x. You can solve for that number, and of course that's going to be 4. So then, what I always do with this sign right here in front, if this is a plus, I'm going to put a plus here. If this is a negative, I put a minus here so I don't have to worry about my signs. So this is a plus, and of course then it's 4. And then it's the same thing as doing it's the same thing that is doing as 4 times x plus 3. We distribute the 4. We get 4x plus 12. And this part right here is basically 4 times this. And that's going to be written right here. 4x plus 12. Just like in long division, you subtract. Because you have multiple terms, use your parentheses because subtraction goes to everything. Now you get 4x minus 4x, which is 0. And you have 12 minus 12, which is 0. Therefore, my remainder on this, we can actually write as plus 0, because that's my remainder, over x plus 3. Now, on this page, on the opening page, if you read the last paragraph, I give other examples of what you can actually do with the quotient and the divisor, different ways you can actually work this out, how x plus 3 and 2x plus 4 are actually the factors of the dividend, because it has a remainder of 0. On the next video, we're going to dive into synthetic division. This was a review from Algebra 2. I'm going to allow you to have multiple ways to actually solve as we get into actually graphing the polynomial.